We are going to pass this flash drive for the next section. The next section is the training proper. So I think needed for the training. So we are going to pass this flash drive for those that have their laptops with them, their system. We are going to put that into your system. That's snappy. As soon as you done that, pass to the next person so that we can start the training proper. So the training is data analytics and visualization, and this session is going to be anchored by the host of the program, Mr. Adeyinka Adegoke. He's an erudite scholar, founder of Intrigue Pathways, project lead, My SDG at Mind the Gap Community and Youth Development Foundation. He's a top-notch program manager and presidential awardee for impactful community development. Please, let's give it up for our host. Let's appreciate him.
Thank you so much. So we don't have time. We have to start the training immediately. What's time now? So let's assume we are starting by 2, and let's hope the training will end by 4, so that we can start the debate. Now, I will need my slide. What is data science? Data science is what I can call the elder brother of data analysis. How to get that? So it's a deep study of a massive amount of data. Data analysis can be done with, let's say, a limited data number. Let's say the number of rows, 100, number of columns, limited. But then when you have what we call a big data, like what we have in all these big organizations like Facebook, like Amazon, like AWS, big data, that's when data science becomes very important. Also, we can have data in a structured form, and we can have it in an unstructured form. When data is not structured, of course, data analysis may not be able to help. You will need the big brother, which is what? Data science. So when you have a massive amount of data, which involves extracting meaningful insights from raw, structured and unstructured data that is processed using the scientific methods, different technologies, and algorithms. That's when we talk about data science. So, as a data scientist, just like we saw somebody the other time, we interplay with different disciplines. We interplay with those in the medical field, those in economic field, those in sciences, all fields, even law. You are a multidisciplinary person if you choose to be a data scientist, even if you choose to be a data analyst. As a data analyst, you get people from other walks of life coming to you that I need your help with so and so analysis. People in geography, they'll come around. People in agriculture, they'll come around. Nursing, they'll come around. And so data science, and by extension too, data analysis is a multidisciplinary field that uses tools, techniques to manipulate data so that they can find something new, something meaningful, insight. So now, data science, these are definitions of data science, combines mathematics and statistics and computer programming, advanced analytics, artificial intelligence, machine learning, with specific what subject matter. The subject matter may be in agriculture, it may be in medical field, it may be anatomy, agri, engineering. All other disciplines are connected to statistics and artificial intelligence through the field of data science. So these insights, that's what data science and data analysis has as its major goal. You want to generate insight. You want to be able to make decisions, what we call informed decision making. That's the primary goal of data science. We want to make informed decisions. So in short, we can say that data science is all about asking correct questions, that's the data collection, modeling the data using various algorithms. So we're talking about various algorithms, both the simple one and the complex one, and how to make choice of your appropriate statistic to understanding the data and what's that final one to make better decisions and finding the final results. Alright, data science life cycle is starts with data collection and storage. We move to data preparation, which encapsulates the data cleaning. So that's the data preparation. Let me go back there. Encapsulate a lot of things, ensuring accuracy, removing duplicates. Actually, in the field of data science, you spend much time on data cleaning, trying to prepare your data for analysis. That's where the major work is actually involved. Now, we have data analysis and visualization, which is the real work that you want to do today. Predictive modeling is the advanced form of data analysis. After you're done with the data analysis, which is the descriptive statistics, the inferential statistics, now you can start talking about predictive modeling, and thereafter we have the interpretation, which is the data storytelling. Now, I'm trying to be very fast. I want to skip some things, so because of our time. Alright, now let me now come back to just data analysis. Data analysis. What do you do as a data analyst? Cleaning, sorting, shaping information to find information, and that's what is regarded here as what helpful stuff, and make what decisions with it. That is what data analysis is all about. At least you have come from this program. One thing that you should take away is that what, as a data analyst, you are after what? Informed decision making. You are trying to take data in its raw form and convert it to what? Information. The process of converting data to information is what? Anybody? Data analysis. It's very simple, right? The process of converting raw fact to information is what? Data analysis. So why is data analysis important? We use data every week, data everywhere. We have so many data that has been collected today, data on attendance, data. You can generate a whole lot of data with this event, what has taken place today, and you can now consider an organization like Google. People are uploading different stuffs every time. So the data on a single day is going to how many billions. The same thing with all these top tech companies having data. Like on LinkedIn, how many posts are coming in on a daily basis? So many. So data analysis helps to turn, help to clean, help to sort, help to shape information to find helpful stuff. And we said that in our world where we use a lot of data, data analysis helps us to make smart choices, work better, and come up with what? new ideas. Types of data analysis. We have the descriptive analysis, we have the diagnostic analysis, I'll try to explain them. We have the predictive analysis, and we have the prescriptive analysis. Let's start with the descriptive analysis. That's where we have you trying to summarize. Like, okay, let me ask you to just stand up. Yeah. To describe our sister here. Who wants to describe her? Just volunteer to give a little description. Yeah, my brother in black suit.
The sister across there is a tall, chocolate skin, smiling.
Okay, she's tall, she's smiling.
She's chocolate skin.
Very good.
She's putting on a black mixed color.
Is that black? Black is some design.
She's putting on a chain.
Alright. So all he's doing is what? He's trying to summarize, he's trying to describe a particular person. So what he's doing now is what we call data collection. Analysis. Is it not doing analysis? It's helping to analyze. Okay. An analyst can come here and say, okay, how many males do we have in this auditorium? Let's say we have 24. How many females? We have 75. That means we have done which type of analysis? Descriptive analysis. So you are finding the frequency of the age distribution, the gender distribution of the event. Also, we can go for the age as well. Okay, somebody may just, maybe one of the management may just come around and say, okay, I want to know the age of everybody. You have 16, you have 34, you have any 25, you know, like that. And all of us, and said, okay, give me the mean age of everybody. That means we add up all the ages and we divide by our total number to get the mean age, right? That's what type of analysis? Descriptive analysis. Someone may ask, okay, what's the range, age range? Okay, maybe the minimum age here is 16 and the maximum age, let's say 35. By the time you subtract, you get what? The age range. What are you doing? Still descriptive analysis. And so many other things like that. But now, when you are trying to say, okay, what's the impact of age distribution or what's the gender on a particular phenomenon, that is, we are now moving to what type of analysis? Diagnostic analysis. You want to know why. That is, seeks to identify the causes, the impact of something on the other thing. That's, we are trying to know the cause and effect relationship. So that, what type of analysis is that? Diagnostic analysis. After that, we have the predictive analysis. That means we are trying to make a future forecast of what will happen in the future on the basis of what has happened in the past. That is predictive analysis. And that's where data science comes in. After that, we now have the prescriptive analysis, which is on the basis of the information we now have, what are your recommendations? So a predictive analyst, a prescriptive analyst must be able to give solutions. Not just knowing the causes, but also be able to provide solutions. So that's prescriptive analysis. Now I'm now going to Python as I promised. Of course, those are places where a data scientist can work. We have so many places like that. I've said I'm not going into that. Let's start with measurement. I don't know. Where is the second mic? Is the second mic available? Please, I want it to be interactive. So I will be asking us to say one or two things. I want one of our debaters to describe, and this may also come with a prize. Just define what is merriment. What is merriment? Mr. Olagunsoye, give the mic to any of the debaters who is volunteering to do that. Definition of merriment.
Merriment is a form of quantifying something.
I can't say it.
Merriment is a form of quantifying something.
Form of quantifying something. Another person.
Measurement is a form of quantitative analysis that someone can use to know the scale and size of objects or entities.
Please say it again.
Measurement is a form of quantitative analysis that one can use to know the scale or size of an object or entity.
Alright, thank you. What if it's not quantitative? Like the name of your department, is it quantitative? Alright, we'll get to that. Any other person helping us? Okay, let me give you my own definition. Merriment is the process of assigning a value or a score to an observed phenomenon. A particular value or a score to an observed phenomenon. Do we have psychology students here? Anybody from psychology department? Psychology? Okay. I want to ask, it's not only limited to psychology students. Actually, even nursing and everybody will do it. How many scales of merriment do we have? Scales of merriment. Anybody? It's a popular phenomenon. I believe we should have answer to that. Alright, because of time, we have 4 scales of merriment. 4 scales of merriment. We have what we call, anybody? Yeah. Okay. Mr. Olagunsoye.
We have the nominal.
Nominal scale. Next one. Ordinal scale.
Interval.
Interval scale.
Ratio.
Fantastic. Let's start from. This is the beginning of data analysis. Let's take it very serious. It's better we have it as interactive as possible because we will need all this information by the time we start. So the nominal scale, the ordinal scale, the interval scale, and we also have the what? The ratio scale of analysis. Now let's start. Yeah. So let's start with the nominal scale of merriment. What is the meaning of nominal? Nominal means what? Huh? Nominal means names. Nominal means what? Names. Now, what's the name of your department? Pharmacology. So which scale of merriment is the name of your department? Scale of merriment. What's your name, my sister? Your name? The merriment is that everybody, anything that has to do with name is what? The nominal. That's the most primitive scale of merriment. And why did he use the word primitive? That means it's at the minimal level. And there's no sense of order between one merriment and the other merriment. We can't say that faith is greater than marvelous. We can't say that medicine and surgery is greater than pharmacology. They are just what? Names. Chocolate and light. We can't say chocolate is greater than light. They are just what? Different names. Colors. Yellow, pink. They are different colors. So there is no sense of order in the merriment. So when the merriment doesn't have a sense of order, we call that what? nominal scale of merriment. Now let's move to the second one, ordinal scale of merriment. I will talk about the ordinal scale of merriment. That means there is the word ordinal has a root word, which is what? Order. That means there is a sense of order in that word, merriment. It means that we have one of them to be greater or better to the other. For example, first class, second class, third class. Everybody knows that first class is greater, better than what? Second class. So which scale of merriment is that? Ordinal scale of merriment. Even all these secondary school examinations, A1, B2, we know that A1 is better than, let's say, C. That's what? Ordinal scale of merriment. Let's move to another one. Let's say, who can give me an example of ordinal scale of merriment? Ordinal, that has a sense of order. Let's say always, all these liquor scale questions. Always, often, occasionally, rarely, what's the last one? Never. That means always is what? Is having a higher frequency than what? Occasionally. That's also what? An ordinal scale of memory. There's an order in it. But one thing that we should take note of is that both the nominal scale and the ordinal scale, they belong to a family of what we call variables, known as categorical variables. We are going to deal with variables soon. The nominal scale and the ordinal scale belongs to which type of variable? Categorical variables. Take very good note of that. Now, I'm coming. Okay, I think we have it here. Alright, let's talk about the interval scale of merriment. The interval scale of merriment, that's where we have numeric, like a numeric variable. Then now, let's talk about temperature. Chemistry students in the house. Pharmacology, due to your chemistry student. All the chemistry students, I want to ask you a question. What's the possible, minimum possible temperature possible in degrees Celsius? Minimum temperature possible in degrees Celsius. Our moderator, I know you're a chemist. What's the minimum possible? Because I still remember my Boyle's law, Charles law, all these volume laws. So what's the minimum possible temperature in Celsius? Use the mic. 100 degrees Celsius, depending on who you are. So the minimum possible temperature in degrees Celsius is 0 degrees Celsius, right? Any other person that wants to try? I know you very well. Let's give it to pharmacology.
I believe the minimum temperature goes less than 0.
What is the figure? Because when I in interval scale of merriment, you have to be specific. Yes, specific.
I believe that's the figure, but it goes beyond.
So nobody in the house, some people want to say, okay, someone is there. -89. So it's possible to get a negative temperature, right? You can have -4 degrees C, like deep under the water. Okay, but I'm still not seeing the right answer. Anybody? Wow. Degrees Celsius is -273 degrees Celsius. -273 degrees Celsius. That's the minimum. So it's possible to get what? maybe minus 272 degrees Celsius. Yes, you can do that in the laboratory. But when it becomes minus 273 degrees Celsius, the volume is also what? 0 meter cube or 0 centimeter cube. Anytime it's possible for you to get a negative value in your measurement, that means the scale of measurement is what we call interval scale of measurement. And the challenge with interval scale of measurement is the presence of what we call arbitrary 0 point. When the 0 point is not a true 0 point, it's a false 0 point, we call the scale of measurement what? Interval scale of measurement. That's why when you're doing the graph of temperature, it doesn't start from the origin. If it is degrees Celsius, it starts from, there will be an intercept, and that's 273. So it starts from minus 273 degrees. So let's take note of that. Now, there are so many IQ scores, we can have negative values. So many other examples that we are still going to talk about. Even day of the week is interval scale. Why? Because there is no starting point. The official starting point is maybe Sunday or Monday. But then before that time, we had a day. So that's what interval. Even days, what is it? 0000. We had 11:59 before that. So that's the what? Interval scale of measurement. But then, don't forget that when we talk about the interval scale of measurement, we are talking in terms of numbers. It will be specific. Maybe 4.72, that's what? Interval scale of measurement, minus 4, you know. Now let's talk about ratio scale of measurement. Yeah, just like the interval scale of measurement, ratio scale is also in terms of numbers. But there's a good thing about the ratio scale, and it's actually the most advanced scale of measurement, and that's the presence of what we call the absolute 0 point. Absolute 0 point. The absolute 0 point talks about 0 degrees C or 0, anything, the measurement, not 0 degrees C now. Starting from 0, that means it's not possible for you to get something less than 0 degree. I mean, less than 0. You can have so many examples in that regard. For example, let's start with the temperature. Temperature in Kelvin. Let's leave the degrees Celsius. The minimum possible temperature in Kelvin is what? 0 Kelvin. You can't have anything less than 0 Kelvin. Do we get that? So temperature in Kelvin is which scale of measurement? Ratio scale of measurement. Very important. Ratio scale of measurement. So don't let us forget the 4 scales of measurement. We have the nominal scale, we have the ordinal scale, we have the interval scale, and we have the ratio scale. One thing worthy of note is that both the interval scale and the ratio scale of measurement belongs to a type of variable known as what? Numeric variable. Numeric. Now, we said that the nominal scale and the ordinal scale belongs to a type of variable known as what? Categorical variables. And we said the interval and the ratio belongs to another known as what? Numeric variable. So what is a variable? Anybody? I need somebody to give me that answer. Any volunteer to do that? Yeah, please. I like this, the native here. Yes, what's a variable? You may not have a definite answer for it, but let's see how you can. Huh? No, I don't want that particular definition. Something simpler. Not what is on the board. If you copy what is on the board, you have to. And you can also look at what is on the board and see if I just want to see another person to try. Let's take another person.
Like what you explained here, that they can keep any value. But sir, let's put it in another sense. Variable is anything you can assign anything of value to. For example, you can declare a variable.
You can assign
something of value to.
something of value.
Yes.
Wow. No. Okay. Somebody is talking there.
Something immune. It means something that can change.
Perfect. Excellent. Anything that's what's the root word of the word variable? Anything that varies is a variable. 100% score. So anything that can change, anything that can exercise change in magnitude, change in direction is what? A variable. For example, pregnancy status. What are the possible values? Medical people. Huh? Okay, give it to nursing. Medical, so pregnancy status. What are the possible values of pregnancy status? Very fast, please. Nursing.
It's either it is positive
Or
negative.
excellent. Positive, negative. So how many are the possible values? 2. So we'll get into that. So pregnancy status is a variable. Sorry, I didn't mention much of examples under ratio scale. We have the weight, we have the height, we have the length, distance, temperature impairment. The minimum possible weight is what? 0 kg. And that's what we call weightlessness. I hope you get that. The minimum possible distance is 0 meters or whatever units you want to picture. Or have you seen distance in negative? It's not possible, right? So that's ratio scale. Now let's move to variables again. We said anything that varies is a variable. And this is actually the beginning of what? Data analytics, data analysis, and the rest. So now let's talk about categorical versus numeric variables. Categorical variables are variables in form of classes. Like we have departments, Department of Anatomy, Department of Microbiology, Department of Plant Biology, and the rest. So that's different classes. That's what type of variable? Categorical variable, followed by what? A numeric variable, which is what? In form of specific values. 2, 3, 2.5, all those ones are what? Numeric variables. So when you have variables in form of numbers, for example, how many children do you have? You have 4, you have 5, you have 0. Also, what's your age? It's also a very good example. 2 years old and 3 years old. That is what? A numeric variable, very important. Now let's come to the other classification of types of variables. We have independent versus dependent variable. Because of time, I won't be asking us that what is the meaning of dependent, what is the meaning of independent variable. But I believe some of us, we actually have a background knowledge in this. Maybe not all of us. Now, when we talk about independent variable, we are talking about a variable that is, we usually have independent versus dependent in a type of analysis known as bivariate analysis. That means in the research question, we have just 2 variables. It can be more than 2, but at least we need to have 2 variables. So whenever you have 2 variables and one variable is depending on the other, that means the variable that is depending on the other variable, which is not depending on anything, is the what? Dependent variable. Why that one can stand alone? That is actually doing the cause, doing the impact is the independent variable. So technically, we say a dependent variable is the variable that is being manipulated in the research process. The variable that you are trying to manipulate and check what will be the response on the other one is what? The independent variable. Some people will say, okay, what is the impact of the age at marriage on number of children? What is the impact of age at marriage on the number of children? That means something is causing something to happen. So in that research question, let me ask us, how many variables are in that research question? Question and answer, moderator. How many research questions? I want you to go to the far back, those people at the back. I want to hear from them. What is the impact of age at marriage on number of children? How many? The first question. Yeah, someone is raising up their hand.
The age of marriage and the number of children.
Not age of marriage, age at
marriage. Right?
No, okay. Still with you, still stay with him very well. Which one is the independent variable and which one is the dependent variable?
The age of marriage is the independent variable and the number age at marriage and the number of children is the dependent variable.
Why? Okay, depending on what?
Yes, on the age at marriage.
Excellent. Let's start from it. So we will try. Very good. Now, I don't want to take contraceptive use. Does level of education affect contraceptive use? Just look for somebody that is well dressed and give it to the person. Appropriately dressed, give it to the person. The blessing can be the impact of blessing on
the blessing again, sir.
Yeah. I can't tell you how many variables are there.
The question again.
Okay. Does level of education affect contraceptive use?
Yes.
No, I'm not asking whether it is yes or no. It's a research question. You will do the research and come with the answer. So you don't predetermine that this is the answer. Now, how many variables are in that research question? Where is the person? Okay. Okay. What are they? Does level of education affect contraceptive use?
Level of education and contraceptive use.
Excellent. Which one is independent and which one is independent?
Level of education
is what? Okay, and the other one is what? Excellent. You also got it right. Okay, let's come to the debaters. Let's come to the debaters. I want to ask them my questions. Does family income, okay, let me say, does number of children depend on family income? Yeah, I can see you would like a chocolate person. Pick the mic. I want you to camera the person. Okay, does number of does number of children depend on family income? I'm not answering yes or no. Two variables, yes. Which one? Huh? What are the variables? I want the whole Nigeria to hear you.
Family income and number of children.
Okay. Yeah, excellent. So which one is dependent? Which one is independent?
Family income is independent and number of children is dependent.
Perfect. So I want to, on the basis of those three, make a generalization about about the entire number of students here that we understand the concept of independent and dependent variables. Sample of those three persons. I believe those three are representative. The debater, the other one native, and the other one corporate. Alright. Now let's move to another classification of types of variables. We have the continuous versus count variables. Continuous. When do we say a variable is continuous? And when do we say a variable is count? Before we can say a variable is continuous or count, it has to be a particular type of variable known as numeric variables. All together? So, if a variable is not numeric, it cannot be regarded as continuous and it cannot be regarded as count. So now, continuous variable is when a variable, of course a numeric variable, is such that between one value of the variable and another value of the same variable, there can always be a middle value. That is, you can always generate a middle value for that variable. That is what we call continuous variable. Any variable that can be in the form of decimals, that can take up decimal values, is what? A continuous variable. Any variable that can take up fractions, 1/2, 2/3, that is what? A continuous variable. Now we move to the other one, which is the count variable. When do we say a variable is count? Are we together? Please, let's have one else. When do we say a variable is count? A variable is count when, let's say, we have any variable that can take up only whole numbers, integers. That's what we call a count variable. Are we together? Any variable that can only take up values in the form of whole numbers is what? A count variable. Now let's talk about dichotomous variable. I believe the flash drive is still with us. It's helping monitor the flash drive. Then, where is the flash drive? Yeah, give it to them as well so that the speed can. Alright. So we talk about dichotomous variable. Any variable that can take up only values in form of what? That can take up only two values, like gender, male and female. That's what type of variable? Dichotomous variable. That is 2. Now, pregnancy status that we discussed the other time, positive, negative. That's which type of variable? Dichotomous variable. HIV status, positive and negative. That's what? Dichotomous variable. Now let's talk about extraneous variables. You will agree with me that in real life, we always have different factors affecting something. Like we said the other time, what's the impact of age at marriage or years of schooling on age at marriage? It is not only years of schooling that affects age at marriage. We can have other factors also coming into play, but those factors coming into play of which we are not interested in working on in our research is what we call extraneous variables. Any variable that also affects a dependent variable but of which we are not interested in considering in our study is what we call extraneous variables. I believe that is clear. Alright, so let's move on. Yeah. Also, we have primary data, secondary data, structured data, unstructured data. Because of time, I want us to move to practicals. But before we go into practical again, there are still some things we need to talk about. What's time now? And we said 4, right? Once is 3, let me know. Yeah, we move to practicals. but we have to quickly, this short period of time, let's finish this particular part we are going into. And that's what we call choice of appropriate statistic. Choice of appropriate statistic. There are two, what is statistics, collecting data, and the rest. You can look into that. But definition of statistics, division. How many types of statistics do we have? Anybody? Two types. We have the descriptive statistics and the inferential statistics. All the statistics you are exposed to in your secondary school, media mode, OGIF, cumulative frequency curve, which other one? Range, standard deviation, mean deviation, which other one? Variance. All those things, they are what? Descriptive statistics. That came back to what we were doing the other time, trying to describe our sister. So, but then we want to move to a deeper form of statistics, which is what? The inferential statistics. Inferential statistics, that's when you are trying to make inference or generalization about a population on the basis of a sample of that population, just like we did just now. On the basis of three nice cases here, we were able to make generalization because I believe that those three, they are enough as a representative sample of the entire population. Now, inferential statistics. Also, another thing I want us to take note of under descriptive statistics is it belongs to a type of analysis known as univariate analysis. Univariate really means what? One. So one variable. But when we come to inferential statistics, the minimum we can have is two variables, and that's what we call bivariate analysis. Now, if it is more than two, we call it what? Multivariate analysis. Are we together? Now, let's start with bivariate analysis. Don't forget the topic, choice of appropriate statistic. Single statistic. Now, how do we make choice? Okay, these are the statistics we want to work on. Now, let's start with a scenario where a particular variable is what? Categorical. You know the meaning of categorical variable? Gender is categorical, occupation is categorical, marital status is categorical, they are form of classes. We have single, we have married, we have divorced, we have widower, we have separated, single mothers. Those are classes, categorical variables. And now you appreciate what we have discussed in the past. When we have two categorical variables in our research topic, in our research question, we are going to use a particular statistic known as what? Chi-square. Chi-square. That is an example of what? An inferential statistic. Nobody taught you chi-square in secondary school, but in university you need it, and going forward it's very important. So chi-square is when you have two variables and the two of them are what? Categorical variables. So you need to look at your research question very well. If you notice that two variables there are what? Categorical variables, that will tell you, of course, there are different factors that affect choice of appropriate statistics. We have environment as one of the factors. We have the research design. We have the what we call the normality. Normality talks about the distribution of your data. So on the basis of normality, we can have two types of tests. We have the parametric test and we have the non-parametric test. Now, the parametric test, that's the one we are going to be, we'll be dealing with the parametric test today. We are going to assume that our data is normally distributed. But when the data is not normally distributed, for every parametric test, there is an equivalent non-parametric test. I don't know if you get that. So for all the variables and all the statistical techniques we are going to be talking about today, we have the parametric version and we have the non-parametric version. But for the sake of this class, we will only dwell on the parametric test. Now, let's talk about, we have talked about chi-square. Let me give us an example of a research question that has to do with chi-square. What's the impact of level of education and occupation? Is there any significant association between, what do you look at? You look at the variables there, level of education and what? Occupation. Level of education, what type of variable is that? Categorical variables. Now, the occupation, what type of variable? Categorical variables. Which statistical test are we using? Chi-square. Very good. It's very clear. Now, let's move to the second scenario. Let's assume that in your research question you have just we have one of the variables to be numeric and the other one to be categorical. Let's say the categorical one is the dependent variable and the numeric one is the dependent variable. So there are two possibilities. It's either you are using independent t-test or you are using one-way ANOVA. When in your research question you have one of them to be categorical, the other one is what? Numeric. There are two possibilities: independent sample t-test or what? One-way ANOVA. Unless we're using one-way ANOVA, you look at your categorical variable. If the categorical variable is talking about just two categories, dichotomous, then we are going to make use of what? Independent sample t-test. But when the categorical variable has more than two categories, more than two classes, we make use of what? One-way ANOVA. Excellent. Now let me try to take the slide to where we are. How many variables are in that research question? Is age at marriage in rural area significantly higher than in an urban area? How many variables? Two? Wow, what are they? I need to hear your voice.
Okay, so three.
Okay, what are they?
Age at marriage is one. Residence and the place of residence and age at marriage.
Excellent. Well, you said three. So residence, which is under rural area, everybody can know that analysis. And urban area. Now, I'm moderator, you're not going back. I still want to ask the same person. That's okay. How many categories is that, or before then, age at marriage is what type of variable?
Age at marriage is...
Excellent. How about residence?
Residence is category.
Perfect. How many categories?
Two now.
What are they?
Rural area and urban area.
Excellent. Right. So because it is having just two categories, so which statistical technique are we going to use? Which following? Independent sample t-test. Use of independent sample t-test. I'm just noticing a tone in the house. That's great. Okay, so that's the next question now. Now, okay. Are there differences in mean age and forced intercourse by level of education? So they are permitted to help themselves. How many variables are there? Let's start with that. You have not seen the twin in the house. Twins, they are even looking back to see them. Then you identify those variables. Then we talk about type of variable.
That's variables.
What are they?
Age and intercourse, level of education.
Sir? Please let your voice be louder, okay?
Okay. That's variables, like I said. Age at first intercourse, the level of education.
I can't hear you.
Age at first intercourse,
And
the level of education.
excellent. I'm happy to hear that. Okay. And what type of variable is age at first intercourse?
Categorical age.
Are you sure?
Sorry, remember.
If I should ask you, what's your age at first sexual intercourse? What will you say? Is it psychology? You give me a specific number. Age at first sexual intercourse is not a categorical variable, it's a numeric. You will have to state a specific figure. Now the other one, which is level, what type of is categorical? How many categories? How many classes? What are they?
You can be primary certificate, for instance. So you can also have a secondary school certificate.
So you can have no formal education, primary, secondary, tertiary, like you are here. Alright. So which statistical technique are you going to use for that?
Since it's one, and
Since what?
since it's numerical and categorical, then one way and over.
Why one way and over? Why not independent sample test?
Because there are two different
Because the classes are more than two. When the number of categories are more than two, we make use of one way and over. Do you get that now?
Come again.
When the number of categories of the categorical variable are more than two, three or more, we make use of what? One way and over. But if there are only two classes, two categories, we make use of what? Independent t-test. I hope clear with that. Please, those of us at the back, why not join us in the front? Two variables there which are sales performance, which is numeric, and also location, which is what categorical. And there are only two locations there. We have Lagos and we have Jos. That means we have only two classes. Which statistical test are we using? Independent t-test. The customer crunch rates vary based on customer occupational segment, customer crunch rate, that's numeric, and customer occupational segment, that's categorical, and that's more than two categories. So what do we have there? We have one way and over. Excellent. Now let's talk about when both variables are numeric. Whenever both variables are numeric, we have two possibilities. We are either using correlation or we are making use of regression. We are either doing a correlation analysis or we are doing a regression analysis. When the type of variables are both numeric, we are making use of either correlation or regression. For the sake of what we are doing now, which is bivariate analysis, the correlation is being referred to as Pearson correlation, while the regression is simple linear regression. Two variables, binary analysis. Alright. Now we have both variables and numbers. Look at this scenario. But before then, let me explain the difference now when we make use of Pearson correlation and when we make use of simple linear regression. We make use of Pearson correlation when we are interested only in the relationship between the two variables. We are not interested in this one is having an impact on the other. That means we are taking all the variables, the two variables as independent. They are not depending on the other. We just want to know, is there any relationship, any significant relationship between them? That's when we make use of what? Pearson correlation. And don't forget, we are still dealing with parametric tests. Now, the other one is when we are interested in the cause and effect. Does this one depend on the other? And both of them are numeric. That's when we make use of what? Simple linear regression. Well, we are, okay, does number of sexual partners depend on years of schooling? They are both numeric and we are interested. One is independent, the other one is dependent. So we are making use of which type of statistical technique? Simple linear regression. I believe we are okay with that. Now let's move to, okay, now let's see the examples. Is there any relationship between age at marriage and number of children ever born or parity? So age at marriage, what type? Numeric. I'm interested in just the relationship, right? So which statistical technique are we using? Pearson correlation. We are making use of Pearson correlation. Then, does number of sexual partners depend on years of schooling? So both numeric, but this time around, one is independent, the other one is dependent. So we are making use of what? Simple linear regression. Alright, because of time. We also have multivariate analysis. Don't forget, I said once is it 3? What's time? On the dot. That means we will be going to multivariate level of analysis. We do that one online, and I would have loved to do that. Sorry, because of time.